Hey YouTube, this is a really quick overview of quadratic functions. Okay, in this video we're going to define what a quadratic function is, what it looks like, how you identify it, but also a little bit about the graphs, okay, because we're going to be graphing quite a bit of them. So let's go ahead and start with this. We say a quadratic function, we could say let a, b, and c be real numbers such that a does not equal 0. Then we have this. F of x equals ax squared plus bx plus c is quadratic. Okay, so the definition of a quadratic function is any function that can be written in this form right here, where we have basically what I want to point out, a, b, and c being real numbers, and we say a is not allowed to be 0. The only reason I mention that here is because if a were allowed to be 0, really quickly, if I put 0 in here, I would get this here. Plus bx plus c. I would just get bx plus c, which we know is just a line. It's linear. It's first degree right here. Okay, so we want something that's quadratic. So basically, quadratics are things that can be written in this form, but the dead giveaway is essentially the highest power on a variable exponent is a 2. So it's second degree. So second degree things are referred to as quadratic things. So really quickly, we can just write down some examples of things that would be considered quadratic. You know, if I said f of x equals x squared, obviously this would be quadratic. We could also write this as 1x squared plus 0x plus 0. Furthermore, I don't know, we'll throw another one out here. We'll just call this one f of x also. I could say that this is 2x minus 1 squared plus 3, and this would also be considered quadratic. The thing I want us to keep in mind essentially is this. It would be quadratic. Let me switch back over my pen tool here. That's better. It would be quadratic because if I were to FOIL out this term right here, I would get something that's second degree. And furthermore, while I'm on the subject here, we say FOIL something out, this would even be considered to be quadratic. And the reason why is because if we were to FOIL this out, we get x squared minus 2x plus x, which is minus x. And we say minus 2. This would also be quadratic. So for, just a matter of example, those are all quadratic things because we have something squared on it. So now, what do I want to know about quadratic things? Well, first things first, this right here, this is usually referred to as standard form. Okay. When you see something written in ax squared plus bx plus c form, we are going to refer to this as standard form. Now, the only reason I point that out is because we also have another form that is called vertex form, and I only want to mention this. Some people actually call vertex form standard form, but there is also another way that we can rewrite all of our quadratic functions, and the way to do that is this right here. And the only reason I mention this is because we are already used to graphing functions that are in this form. So as a matter of an example, let's go ahead and graph, say for example, this guy here. We'd say, let's not do 2, 3. We'll do 2x minus 1 squared plus, let's go 3. So now when I look at this, what I want to kind of recognize right off the bat is that its parent function is x squared, but what I'm seeing here are some a, h, and k values. And so if I were to point these out directly, we say a, h, and k, I would notice here that my a value is 2 or 2 over 1. We say k, or h is lying, so this is actually a positive 1. It's got a negative in front of it, so it's lying. And we say this 3 here is honest. So what this is going to do, it's going to shift right 1 unit. We are going to go up 3 units, and we have stretch. We have a vertical stretch, okay? And we're not going to have any reflections because this a value is positive. Well, when we sketch this, what it would look like then is this. We said we'd go right 1, we'd go up 3 units, and we would drop this in right here. And what I want us to kind of indicate on this, first of all, is that noticing our parent function, which by the way starts at 0, 0, goes up 1, right 1, also goes up 1, left 1. This is just some shifted form of it. So we're still going to have a parabola, which is the name of our quadratic graph. This is referred to as a parabola. So this part of my parabola, what I want you to understand is it used to be at 0, 0. This part that I've just graphed over here that it's at 1, 3, it used to be at 0, 0. But the reason why I did this is because we did shift right 1 and we shifted 3 units up, but from where? But from 0, 0. So what I want to kind of point out here is this, and we'll go ahead and label this. This is the point 1, 3, but I want to go so far as to say this. For anything that's in this form, that's I'm talking about this up here, then we say the vertex. Vertex is at the point h, k. Okay, so this is really kind of an important thing to know. The vertex is at hk. Now, furthermore, what else do I know about parabolas? Well, I know that they're symmetrical about this line that runs through the vertex, okay? So we always have a line running through the vertex. It's this imaginary vertical line in this case, and we're going to give this a name. This is referred to as the axis of symmetry. Okay, so a few things I want to mention about the axis of symmetry. First one, in this case, would be x equals 1 for this given equation right here. But I would like to go so far as to point out this. In all possible cases, since this vertical line has to go through the vertex, then the x value of the vertex would have to be the same as the x value for our vertical line. Okay, so this axis of symmetry, we could say is this. We'd say the axis of symmetry, which is abbreviated AOS, is at x equals h. And the reason why I say that is because it has the same x value as a vertex here. Okay, so to draw the rest of this, all we need to do is look at the a value. And recall that our a value was 2 over 1, so I'm going to go up 2 as I go right 1. So as I go right 1, I'm going to go up 2. I'm also going to go up to left 1 because I know that this is a parabola and it looks like this here. But this would be sketching our parabola. So in terms of parts of a parabola to know, you always want to know where the vertex is. And you always want to know what the axis of symmetry is. So essentially, we could just come up with some new g of x here. We'll go ahead and throw this out there. We say negative a half. We say x minus 2 squared. And I'll just leave it at that. But again, we say a, in this case, a is negative a half. We say h, in this case, h is positive 2. And k, we have no k, so it's 0. Okay, so if that's the case, and I want to sketch this and label the axis of symmetry and label the vertex and label one other point on my graph, then this is all we need to do. We need to go right 2 and up 0. So we'll go right 2, draw a dot. This is our vertex. Now looking at my a value, this means that from here I'm going to, and this is important, I'm going to go down a half, right 1. So as I go right 1, I've gone down a half. Okay, and since it's a parabola, we know that it's symmetrical about this axis of symmetry. It also goes down a half, left 1. Okay, so here are the things that I would intend to do when I sketch a parabola. Okay, other than be able to tell me where the vertex is, just some h and k, we say 2 comma 0. This was our h and our k value right here. But we could say label some more points on my graph. So this would be 3 comma negative a half, and then this would be the point right here. This would be 1 comma negative a half. All I did was deviate from this original 2, 0. Okay, and the last thing we want to do is label this axis of symmetry, and it's always going to have the same x value as your vertex. We say x equals 2 is our axis of symmetry. That's how you sketch a quadratic. Cheers.